The last variant that we'll see of these distance rate time problems happens when we have a certain allotted time that we split up into two legs of the trip. And this is something very similar to what we saw with the age problems. If you have a total time of 8, if you know that you spend 1 hour going somewhere, that leaves you 7 hours to get back. If you spend 6 hours going somewhere, that leaves you with 2 hours to head back. Well, same idea, even if it's a general time of t. Your time to head back is just 8 minus t. That means that when we have a total time, we can just use t for the time, and the total minus t for the other time. For the time heading out, we'll use t. For the time heading back, we'll take whatever our total is and subtract t. Looking at example 1 here, it says Lupe rode into the forest at 10 miles per hour, turned around and returned by the same route, traveling 15 miles per hour. Her total trip took 5 hours. Her trip has 2 legs. For part of it, she was moving at 10 miles per hour. For another part of it, she was moving at 15. If she took t hours going out, the amount of time she'll spend getting back is simply 5 minus t because she was gone for a total of 5 hours. And the thing is that we know that she's making a trip out, she's making a trip back, so we know these two things have to be equal to each other. And so we have 10t equals 15 times 5 minus t. We simply solve this and we're all set. We'll use the distributive property. 10t equals 75 minus 5t. I can simply add 5t to both sides here. That gives me 15t equals 75. Very easy from here. I just have that coefficient of 15. I'll just divide by it. And we get that t equals 5. Riding into the forest at 10 miles per hour, she spent 5 hours riding into the forest, which left her 3 hours to get back, and the total trip took 8 hours. Let's take a look at example 2. Ian went on a 230-mile trip. He started by driving 45 miles per hour. So for the first leg of the trip, he was traveling 45. For the second leg of the trip, he was traveling at 25. He spent t hours moving at 45. That leaves 8 minus t hours at 25. And it says here that the total trip was 230 miles. So this is similar to the other kind of problems we did because we're going to add these two distance expressions together. Remember, each one collectively represents a distance, and they add up to 230. Same idea as before. We'll just distribute 45t plus 200 minus 25t equals 230. Just like that. It did say that the trip took 6 hours, so let's fix one minor typo I have here. That's not 8, that's actually 6. And 25 times 6 is, in fact, 150, not 200. Sorry about that. All right, let's continue. 45 minus 25 is 20t plus 150 equals 230. I will simply subtract 150 from both sides. We get that 20t equals 80. And again, just like with the last problem, we'll divide by 20. And t equals 4. Now they ask us how long did he drive at each speed? Well, he started driving 45 miles per hour. That leg of the trip took him 4 hours. Then he slowed down and went 25 miles per hour. That part of the trip took him the remaining 2 hours, which adds up to a total of 6 hours.